Okay, so we're going to talk about exponential equations and one way to solve them. And they use what's called the one-to-one property. And it says this: if you have a base to some exponent and it equals the same base to some other exponent, then the exponents have to be equal to each other. So think about it. You know the two sides are equal and they've got the same base. So that means the exponents have to be equal, okay? I call it the pop-out. You're taking the exponents and looking at that equation. You're not dividing by a or anything. You're just focusing on the fact that the exponents have to be equal because you already have the same basis, okay? All right, so we'll show you a few examples. On this one, we have 3 to the 3x minus 2, and they want us to solve for x. So I can write 3 to the 3x minus 2 equals, and then what I want to do is I want to think about 81. Well, 81 is 3 to the 4th power. So I'm trying to get my bases to be the same. So I'm going to replace the 81 with 3 to the 4th power. Now I can use that property we were just talking about because the bases are the same. So I have a 3 here and I have a 3 here. So pop out the exponents and write 3x minus 2 equals 4. So you're saying this exponent and this exponent have to be equal to each other because they both have the same base and there's nothing else going on in the equation. Okay, that's a linear equation now. This right here, that's linear and we can solve that. Add 2 to both sides, divide by 3. And so you're able to solve it. We get x equals 2 in this case. Okay? So I always like these problems. I think they're kind of fun. But the trick is to get the bases to match, and then you can set the exponents equal to each other.